This is question 20 from exercise 21.1 in Project Maths 2. We have to let f be the function f of x is 5x minus 4 and let g be the function g of x is 3x plus 1. Using the same axis and scales, we have to draw the graph of f and the graph of g for the domain 0 is less than or equal to x is less than or equal to 3, where x is an element of R. Then, from our graph, we've got to write down the coordinates of the point of intersection of the two lines, and then we have to verify our answer to part 2 by solving the equation f of x equals g of x. That's a lot, but we'll take it step by step. We're going to use these two tables here to help us graph our lines. So since both of our functions are linear, neither of them have a power larger than x to the power of 1 in them. So there's no x squared, there's no x cubed, there's nothing larger than that. It means that they're linear. So we only need to get 2 points on each of them and draw a line in between them. So we're going to use either end of our domain. We're going to use 0 and 3 both times. So we're going to use 0 and 3. We're going to use 0 and 3. And what we're going to do to get the corresponding y value for our points out of this is we're going to put these x values into our function. So in place of x. So we're going to have 5 times 0 minus 4. We're going to have 5 times 3 minus 4 in our f of x. And the result we're going to get out of these is going to be minus 4. And for this one we have 5 times 3, which is 15. And 15 minus 4 is 11. Which means our 2 points on f of x that we're going to draw are going to be 0 minus 4. And we're going to draw the point 3, 11. Then on our g of x, we're going to put 0 in to our equation in place of x. So we're going to have 3 times 0 plus 1, which just gives us 1. We're going to have 3 times 3 plus 1, which will give us 10. So our 2 points on this particular one are going to be 0, 1 and 3, 10. And we're going to plot those points and then draw a line in between them. First we're going to plot 0 minus 4. So that's 0 across, add 4 down. So that is down here. And then we're going to plot 3, 11, which is 3 across and 11 up, which is just up here. Then we're going to plot 0, 1, which is 0 across and 1 up, which is just there. And we're going to plot 3, 10, which is 3 across and 10 up, which is just here. And then what we're going to do is we're going to draw a line between 0 minus 4 and 3, 11, and a line between 0, 1 and 3, 10. And that'll look like that. So that's our 2 lines drawn out. And what we're going to do now is, from this equation, from this graph, we have to write down the coordinates of the point of intersection of the 2 lines. The 2 lines intersect just here. This is where they cross each other. And the coordinates for that are, our x value is going to be 2.5, and our y value, if we go across, looks like it's halfway between 8 and 9. So for part 2, our point of intersection is going to be 2.5, comma 8.5. But we need to verify that. And the way that we're asked to do that in part 3 is by setting the 2 functions equal to each other. So we're going to say 5x minus 4 is equal to 3x plus 1. Exactly as it says in this equation, f of x equals g of x. And now we're going to solve this for x. So we're going to bring all of our x's to one side and all of our numbers to the other side of the equal sign. So we're going to get 5x minus 3x is equal to 4 plus 1, which means 2x is equal to 5. So x is equal to 5 over 2. So x equals 2.5. And now that we have our value for x, in order to get our value for y, we can take this x and put it back into either of our functions. We'll get the same value either way. So if we get the, let's say the g of 2.5. We get 3 times 2.5 plus 1. Well, 3 multiplied by 2.5 is 7.5, and 7.5 plus 1 is equal to 8.5. So what we have found now is that they intersect when x equals 2.5, and when x equals 2.5, then the y value will be 8.5. And that has verified our answer from part 2. And that is that.